Hello everyone, myself Abhishek Raj Singh, PhD candidate at IIT Bombay, India. I'm presenting this research on AR-enabled informative design to plan site layouts that I have co-authored with my thesis supervisor, Professor Venkata Santosh Kumar Delhi. To start with this presentation, let's have a look at the agenda. We will discuss and understand the role of architects in the AEC industry, that is architectural and engineering and construction industry. Following it, we will discuss the problem of site layout planning. Here, the acronym has been used as SLP. To benefit the problem of site layout planning, we have developed a framework and it would be demonstrated in this research. And there are a few conclusions that have been drawn, so we will discuss them. To start with, let's see what are the role of architects. And it's undoubtedly that I will agree that these are the people who are backbone to any construction project. Their primary job is to provide design documents. And these design documents not only just represent aesthetics, but also include technical considerations. It has been found in previous researches and existing literature also indicates that cross-discipline involvement is something which is only one way and is limited. That is, involvement of people from other disciplines like planning and construction in the design phase is there, but architects are very seldomly involved in tasks like planning or construction of a project. So since there are few literature which have indicated that involvement of architects at the very initial phase of the projects can benefit the project in whole, let's understand the process of site layout planning. It's a process of allocating a space to temporary facilities. And by temporary facility, I mean the facilities that are there to aid the main construction and are to be located on construction sites for a short tenure. These are the facility which uses some space on a construction site, and therefore this problem turns out to be optimum space allocation problem. It's found that in current practice, these 2D drawings and 3D representations are utilized to plan the site layout planning. And there are undoubtedly some limitations to represent site which makes the process inefficient. And since there are some limitations in the existing practice, it adversely influences the project evaluation factors like productivity, quality, and safety. And since the temporary facilities are to be allocated on a construction site, it's a kind of decision-making problem and which is being executed at the very initial phase of the project. So how we have benefited the planning aspect or the site layout planning is by integrating the major component of any decision support system, that is data, model, and an interface. By data, what we did in this research is we employed building information modeling, from where we got the BIM model for, say, a construction project. Following it, we developed optimization model to represent a construction site. And this optimization based model is purely mathematical, and hence therefore to understand it well, we have developed an augmented reality application. And there are few inputs which came from BIM model directly, like some 3D models in our AR application. Let's see how much we have progressed in this research. So we have completed one-way path, that is from BIM to AR application, but we are in process of pushing back the results obtained to BIM model for better communication among the stakeholders. So the green arrow is the part what have been accomplished till so far. So the data part was generated utilizing BIM model. So we have developed a LOD 300 model for a construction facility, a hypothetical construction site, where there are 5 temporary locations which were identified, and the material quantity were taken out from the MIM model along with the location to the quadrant distance. So if you will see here, the location and distance matrix is this one, and this is the quantity matrix. Following it, the mathematical model was developed. This mathematical model is targeted to minimize the transportation cost on this construction site, utilizing the actual distances on the site. So here the distances were taken from the point of storage to the point of consumption. The equation 1 is representing the unit transportation cost per unit distance. Then this is the distance which has been taken from the BIM model, which represent this LD matrix, location distance matrix, sorry. And XML is the decision variable, which indicates the positioning of temporary facility to any specific location. Here are the constraints that limits this problem to minimize transportation cost. One is to limit the material allocation to a single location at any given point in time. And the another one is to limit the location to hold a single material at a given point in time. Following this, we optimized it utilizing genetic algorithm, and a result was obtained. This is the optimal positioning matrix which we achieved, and this indicates the location of material to a given location. Since you can see that is starting from the beginning of generation of data to achieving this result, it's all numerical, and in absence of any interface, it's a manual interpretation task that comes out. And it's very difficult in absence of sufficient data and sufficient documents to understand these numerical data output. Therefore, to enable practitioners on construction site, it's suggested that if sufficient informative design is being developed at the initial phase of the project, and which is being a part of architects, we can generate this whole sequence of series of solutions that can help people involved in the task of site layout planning significantly. So this AR application, what we have developed is to represent this optimal positioning matrix. So once your application starts, you get the option to select a project. Following it, you will get to know what are the temporary facilities are going to be employed on that construction project. Once you initialize the application, every required temporary facility is set back to 000 coordinate. Following it, once you hit run, so you will get to know the optimal positioning of those temporary facilities. And this is the point where you receive at least a single optimal solution in the pool of solution, which is being generated by genetic algorithm. To visualize it better, you also get an option where you can find that you can go from one solution to another by just switching in tab where it says that you can choose for any other solution. And therefore, this one cycle of data generation to understanding and visualizing result is achieved. And to better understand the implications of the achieved result, the interface also provides you the optimal cost, which has been achieved for that particular layout. So with this, we propose that if architects are involved in this process of site layout planning at the initial phase of the project, then they can generate good informed design documents, utilizing which such great informed decisions can be made. And hence, therefore, to conclude, we proposes that cross-discipline engagement should be there and should be enhanced in our construction industry. And as we have seen that augmented reality based information model is quite it's quite easy to achieve good solutions. And architects are encouraged, and it's proposed that they should get involved in project management tasks to achieve better results. And that's all about my research. Thank you.